In this video, I am going to discuss with you the concept of linked list insertion operation. If you want to suppose going to do the insertion operation, first of all, we need the existing linked list. This is an existing linked list. In this existing linked list, I am going to do the insertion operation. The insertion operation can be takes place in three ways: insertion at the first position, insert at the middle position, insert at the last position. So now we are going to focus one by one. The first one is called as insert at the first position. So consider this is an existing linked list. In this existing linked list, first I am going to create one new node. So initially the first position is considered as L. So we have another statement is called as P equal to L, which means that we can't able to move this position of L into everywhere. Instead of that, we can call with each and every node with the name of P. P in the sense is called as a position. So after that we have to create a new node. So once we are going to have this statement, the new node will be created. This is called as new node. Once the new node is created, initially the next field is become null. And now we are going to read the value of the particular node. For example, if I am going to read the value called as 50. Because of the statement, we have to do the statement like that. Scanf %d ampersand new node of data, which means that this new node field having two parts already. We know that the first one is called as a data field and other one is called as a address field. In this data field, I am going to have the data. So this is a statement to read the value for the given memory space. Once the new node data is fetched, that will be placed in the new node. And now, so we have already existing linked list, and that existing linked list must be connected with the new node. So new node of next, it is initially null because of the statement new node of next field is initially null. So now we are going to have the address of the particular memory space. Then only the new node will be connected to the existing linked list. But the existing linked list having the first position is called as L and another name is called as a P. And now we are going to store the address of the L will be in the position of new node of next. So for that we are going to have the statement is called as new node of next equal to P. So P pointing to the first node of the existing linked list. And now once we make the statement like that, the logical link will be made between those two nodes. And now the connection is made. And now this existing linked node is already, we know that the value is called as a 50. And now once we made the connection between those two, a link is made, and the address of the header node initially is, just imagine, the 1000, and the 1000 will be placed here because of this statement. So once the connection is made, the new node next field having the address of P. And now, so this connection is made. Now this is become the new node only, and now we have to change the name of L to the first node, because the first node is always called as the list begins with the first node. So now we need to change the new node name into L. So for that, L is equal to new node, which means that the new node name will be transferred to L. So the existing new node will be removed and the L will be placed in the position of the new node. So the linked list having the first node is called as L, value called as 50. So this is the way we have to do the insertion at the first position. So initially, if you are going to do the any insertion operation, first of all you have to create the new node. Once the new node is created, you have to read the data, and the new node of next is equal to initially null, and you have to, once the new node is created, you have to read the data as well as the next field is null. Then you have to make the connection between the new node as well as the existing linked list. And now suppose if you want to make a connection, you have to do the statement. So this is a statement, only you have to make the connection between those two nodes. So new node of next field having the address of P, then only the existing linked list will be connected to the new node. So after that the linked will be new node will be added, and finally the total number of nodes also get increased. Suppose if you want to do the insertion at the middle position, you want to insert the new node. See here, the insertion will be takes place anywhere of the middle node. So initially the position will be calculated. The first position begins with the first node. So this is called as the first node, second position, third position, fourth position, and fifth position. Totally 5 nodes are there. And now you have to choose which position you want to place your new node. So I am going to insert the new node in the position of 4. So once you locate the position, you have to move the position from the linked node, the first position. So once you fix the position in which position you want to insert the new node, the pointer should be moved from the first position to the previous position of the current, whichever I choose. So for example, initially the position always pointing to the first node is called as 50. You have to move the pointer position to the next. So for that we need to have some statements. So initially P equal to L, which means that L will be called with another name is called as a P. So L will be called with another name is called as a P. So first of all you have to create one new node and value is called as 60. And initially the next field is become null because of these two statements. So once the statement is created, the new node will be created and name of the node is called as new node. And now initially the next field is null, and as well as we have to read the data for that. So scanf new node of data we need. So which means that once the line is created, we have to read the value called as 60, and new node of next field equal to null, which means that as of now the new node does not contain any successor node. So as of now the new node of next is null and the data field we will be received. And now we have to add this node into the existing linked list. The existing linked list having the value 50, 10, 20, 30 and 40. Now we have to move this node in the position of 4. Already the fourth place is occupied by number value 30. So now you have to move the pointer before the position. So for that I am going to have one statement is called as while I less than position minus 1, which means that I equal to 1 initially, and so I choose the position is called as 4. So 4 minus 1 is equal to 3, and here 1 less than 3 conditions become true. If the conditions become true, we have one statement is called as P equal to P of next. So now the P will be pointed to the first position initially. So this is called as a P, another name is called as L. So now the P will be moved to the next position. So I am going to draw the diagram once again here. So initially this is called as a P and another name is called as L. According to this statement, P will be moved to the next position. Now this is called as a P. And again you have to check the condition. The condition says that P equal to P of next, and we have to increment the position. So here we have to, the statement is called as I plus plus. So I plus plus will be increment the I value. Now I value is called as a 2. So next time we have to check with a 2 less than 3. The condition is also true. If the condition is true, the P will be moved to the next statement because of this assignment statement P equal to P of next. So once the pointer is moved to the next position, again we have to increment the I value. Now I value is called as a 3. So 3 less than 3 conditions become fail. So now the pointer pointing to this position. So now this is a current position. So the new node is already, we know that we already know created the new node. The value is called as 60 and the next node is initially null. Now we need to making a link between those two nodes, the existing linked list as well as your new node. So this is called as a P and this is called as new node. And now the pointer pointing to the third position, and we need to make a connection between third to new node as well as the new node to the fourth node. We need to assign the statement is called as new node of next is equal to, so this is a place I want to, this is the coloring one place, this place I want to have the address of p of next. So what is called as p of next? P of next is called as 3000. So this is the position, the position p having the address of 3000. So this 3000 pointing to the next field. So now this next field having the address of p of next. So we have to write the statement like this, p of next. So whoever present at the p of next is called as 3000, and that should be placed in the position of p of new node of next. And now this 3000 will be placed here. So once the 3000 is placed here, a logical link will be connected between this p of next as well as this new node of next. Okay, so p of next, whoever present at the p of next is called as 3000, and that address will be stored in the position of new node of next. Now one logical link is created, a logical link is created between new node of next as well as the p of next. Once the node is placed like that, next we have to write one statement, p of next must have the address of new node, which means that this logical link will be created because this new node address, just imagine that new node address is called as 6000. So once the 6000 will be placed in the position of p of next, once the address is placed in the position of p of next, and here the value address is called as 6000. Now the node address will be placed in the position of p of next. So because of this statement, the p of next field having the address of new node, the new node address is called as 6000, and the 6000 will be placed in the position of p of next. And now the logical link will be created between the p of next as well as the new node, and the existing link will be broken. So this link will be broken. Why? Because there is no purpose of the link, because the p of next field having the address of new node and the new node of next having the address of initially the p of next. Now the value is called as 30, address is called as 3000, and now this link will be removed from the connection. So as of now the link is created, and now the new node will be joined in the existing linked list. And now still the name is called as a new node, we have to change the new node name into p equal to new node. And now the new node name will be changed into the another name is called as a p, and this is also one of the position in the existing linked list. As of now we have 6 nodes are there, and this is a way we have to insert the new node at the position of middle. So first of all you have to move the position from one position to another position until you reach the wherever you want to insert. The before the position you have to place the pointer, then create one new node, and from the new node you have to point to connection. One is called as p of next equal to new node, and the next one is called as p equal to new node, and then new node of next equal to p of next. So this is a way we have to do the insertion operation at the middle position. Now we are going to discuss about the concept of insertion at the last position. So whenever we are going to talk about the insertion at the last position, you have to create one new node. The new node will be created with the help of the malloc statement, and new node will be created. So now this is called as the new node. Once the new node is created, you have to read the data for that, as well as you have to assign the next field is null. So once the new node is created, we need to add this new node into the existing linked list at the last position. So this is an existing linked list, and the new node will be created somewhere of the memory. For example, the value is called as 60, and the next field is initially null, and we need to make join between those two nodes. So how can you do this statement? Because initially the p pointing to the first node, now we need to move the pointer at the last node. Okay, then only we can able to make the statement to connect this new node as well as the position of p. So now we need to move this pointer to the next place. So we need to have the while statement, while p of next not equal to null. If the p of next is not equal to null, then p will be moved to the next statement because p equal to p of next. So whoever present at the p of next field, now that is called as a p, and now this is called as a p. From the second position we are going to check whether the next field is null or not. If the next field is not null, now move the pointer to the next position, and now the next position is not null, the p will be moved to the next position, and now we are going to check that the p will be moved to the next position. Now this is called as a p, and this is the next field having null field, so the conditions become fail. So as of now the condition will be skipped now to the next statement, and the next statement having p of next is equal to, we need to assign this node address to the next field of p. So just imagine that the address of this field is called as 6000. The 6000 will be placed in the position of p of next. So here we need to have the statement is called as new node, and now this new node address will be placed in the position of p of next. So once the new node address will be placed in the p of next field, the logical link will be created between those two nodes. A logical link will be created. Now the node will be moved to the last position, as well as the new node name will be changed to p because of the statement p equal to new node, and this is become the one of the position in the list. So this is a way we have to do the insertion at the last position. So first of all, we need to move the pointer from the last node, from first node to the last node we need to move. Then we need to make the connection. This is a connection, p of next equal to new node. So while we making the statement, the new node address will be stored in the position of p of next field, and finally the new node also one of the position. So this is the way we need to do the insertion operation at the first, middle as well as the last in the existing linked list. Thank you.